A fun interview question from Citadel. Imagine a gambling house offers a game where you roll a six-sided die. Whatever face value you roll, that's your payout. You start with one roll. If you like the result, you stop and collect. If not, you can roll a second time. If you're still unsatisfied, you can roll a third and final time, and you have to take that value. The question is, what's the fair expected payout for this game? Let's start with the third roll decision. You should only roll a third time if your second roll is less than the average value you'd expect from a single roll. Since it's a standard six-sided die, the expected value of any roll is 3.5. We get this by adding up all possible outcomes, 1 through 6, and dividing by 6. Now, let's move to the second roll decision. Knowing the expected value of the third roll is 3.5, we should only roll a second time if our first roll is less than 4.25. Here's how the expected payout for the second roll is calculated. With a probability of 3 to 6, you will get a roll above 3.5, so 4, 5, or 6, and you should stop, and the average is 5. With a probability of 3 to 6, you'll roll below a 4 and take another roll with expected value of 3.5. So, the expected payout for the second roll is 4.25. Finally, the first roll decision. You should roll a second time, only if your first roll is below 4.25. That means if you roll a 5 or 6, you should keep it. With 2 to 6 probability, you roll a 5 or 6 with an average value of 5.5. If it is less, you roll again with probability for sixths with an expected value of 4.25. Thus, the expected payout of the first roll is approximately 4.67. Therefore, the fair expected payout for this game is approximately $4.67. Were you able to figure it out? Let us know in the comments.